and particularly in this topic we just consider quadratic relationships only, and all quadratic relationships are represented by parabolas. Why we have to learn about this? Is it important in our real world? So the answer is yes, it is very important because it have a huge applications in the real world. So before seeing the application, just let me introduce the two main shapes of the parabolas. So the two main shapes of the parabola is this one and this one. So each parabola we have the turning point. The turning point is the point, for example, it's go up, and at this point it's turning and it's going down. So this one we call turning point, and this also the turning point as well. So this one, the first shape here, we call it is concave up shape, the shape, and this one is concave down. With the concave up, I do not normally say concave up or concave down. I'll say minimum parabola, maximum parabola or minimum parabolas, because with this shape, the value of the turning point here is maximum. So it's maximum turning point. And the value of the turning point of this shape here is the minimum. So there are two main shapes, maximums or minimum. That's what I'll say. So you can see here, the bottom of the Eiffel Towers has the maximum shape of parabolas. The cables of this suspension bridge is combined together and create a parabola shapes. And this one is the minimum parabola shapes. And this one is the maximum parabola shapes. This one, the roller coaster, there's many shapes of parabolas from minimum to maximum. And this one, the roller coaster as well. Or the letter M in McDonald's, they use parabolas equation to design that one. Or the antenna, the parabola antennas, okay? All of this one is used to receive the signal from the very long distance and then reflects to the above here. It's very complicated, but one of the other applications of parabolas is the parabolas antennas to receive the signals from a very far distance. So we're going to learn about the parabolas as we consider, as we understand the importance of parabolas in our real life. Before we doing some application of the parabolas, what we do, we're going to learn the basic thing first, which is plotting parabolas or quadratic relationship in Cartesian plane. And let's start with the simple equation, y equal x squared. This one in this Cartesian plane, this one is y, this one is x, and as long as I have y equals something x, the function of x, then I can represent the relationship of this one in this Cartesian plane. And here x is square, quadratic, so definitely the shape of the relationship here is going to be the parabolas. So how to plot this? What we do, we gonna make a table of values, which is x and y, and we're gonna choose some different values of x to plot out and to calculate the value of y and plot them in the Cartesian plane. So for example, I'm gonna choose x is -2, -1, 0, 1, 2. All right, and if x equals -2, then I substitute back into here. It's going to be -2 squared. So it's equal 4. And this one is 1, 0, 1, 4. Then what you do, you're going to plot them in the Cartesian plane. 1 point, 2 point, 3 point, 4, and the last one. Okay. Now, the first one, the yellow one, x equal -2, y equal 4. So x equal -2, let's make it here. 1, 2, -2. Y equal 4. 1, 2, 3, 4. So this is the point. 1 point. Point A for the yellow. x equal negative 1, y equal 1. Negative 1 here, y equal 1. The second point here, x equals 0, y equals 0. X equal 1, y equal 1, the second point, the fourth point, and x equal 2, y equal 4 here. And then what we do, we're going to connect them all together. You can go furthermore, okay? You can go negative 3, then this one going to be 9. You can go 3, this one going to be 9. So I'll do one more, negative 3, and 4, 5, 6, 7, 8, 9. So 3 and 9 is going to be here. And the opposite one going to be 3 and 9. Here you go. All right. And what you do, you can connect them all together. All the points together. There is curvy rulers selling in office work that you can buy it too. It helps a lot with drawing parabolas. And here you go. This is my parabola shapes of this equation, y equal x squared. And what I'll do, I'm going to write down the equation on top of the parabolas, y equal x squared, to know that these parabolas represent this relationship. So you can see here, this one is a minimum parabolas because the turning point here, all right? The turning point is this point. At this point, the parabolas are divided to exactly the same two parts. This one and this part. So two branches, this and this, they are exactly the same. And they reflect each other through this line at going through the turning point. Okay, so this one we call turning point. I just noted it. We will learn about that later on. And this one, the line that goes through the turning point and divide the parabola exactly two same part. This one and this one exactly the two same parts. Then it is this line, and we call this line is the line of symmetry. The line is symmetry. Okay, and this is how you plot the parabolas. So what you do, you just make the table of values. Now next one is plot this graph y equal 1/2 x squared with the value of x from negative 3 to 3. So for the values of x between negative 3 and 3. And then you have to state the equation of the axis of symmetry. And then you have to state the coordinate of the turning point and the y-intercept for each one. All right, so I have this one already. What I'll do, I have to build the equation of values. The table of values, sorry for that. All right, so x and y, and I'm gonna choose, because this one is 1/2, so I can choose x equal, no, we can't choose, because the minimum value of x is gonna be negative 3, then maximum is 3, so we start from negative 3, negative 2, negative 1, 0, 1, 2, 3. You can skip one of the point here, and you can choose 1.5 if you want. Okay, I just want to make it the unit of each of them is consecutive, so I choose these numbers, and then I substitute negative 3 into this one to find the value of y. So if x equal negative 3, then x squared is 9. 9 divided by 2 is 4.5, and this one is 2. This one is 0.5, 0.5, 2, and then 4.5. And then what I'll do, I'm gonna plot them all. These point one, I'll just make it in different colors. Yeah. All right, I'm gonna plot the point in the Cartesian plane and see what is the shape of the parabolas. So the first one is 0, 0. I can see here 1 point. This one. And this 0, 0 split the parabola into exactly the two same value of y. You can see here the value of y here is 4.52, 0.5, and here 0.52, 4.5. All right. So I look at the table of value. I can see that the turning point is going to be this one. But we just check it out. So if it is -1, then it's going to be 0.5, 1 point. -2 is 2, -1 here. -2 is 2, 1, 2. And then -3 is 4.5, -3, 4.5, and go up. It's 1 here. And then next one gonna be this point of 2, and 3 is here. Oh no, sorry. 1, 2, 3 is 4.5 gonna be in here. And then I connect them all together. And this is my parabolas, okay? Actually, I can draw the parabolas like this, but because the question limits me, it just choose the value of x from -3 to 3. So if x equals -3, then y, the maximum value, the value of y is this one, and x equals 3 here is the value of y here. So my equation only limits in this range, okay? Only. And then next is state the equation of the axis of symmetry. Where is the axis of symmetry? Remember, the axis of symmetry or the line of symmetry have to go through the turning points and divide the parabola into two exactly same parts. So this one gonna be the line. This line going through the turning point, which is 0, 0, and divide the parabola into exactly two branches here. And the line, the information or the equation of this line is x equals 0. So the equation of symmetry line is x equals 0. The next one is state the coordinate of the turning point. You can see easily here is the turning point, okay? And the coordinate of the turning point is 0, 0. And the y-intercept for each one. So what is the y-intercept? It means y-intercept for this equation. Y-intercept when x equals 0, okay? So x equals 0, y equals 0. And this one is the y-intercept as well. Now we move on to the next one. Plot the graph. All right. So look at this one, negative here. Y equal negative x plus 1 square for the value of x between -3 and 1. So here, -3, x and 1. That's what we need to do. And then the same, we have to do the equation of the axis of symmetry, the coordinate of the turning point, and the y-intercept. And again, with this one, we have to construct a table of value, x, y, okay? And I can choose from -3 because it limits me to go from -3 to 1. So -3, -2, -1, 0, 1, that's it. That's what is allowed me to. I can go to 3, to 2 because the maximum value of x here is 1. So just rub this one off. So if x equals -3, I substitute this one into this expression. So -3 plus 1 is -2. -2 square is 4. And negative of this one is -4. Okay, a bit complicated, but you will get used to it. And then if x equals -1, -2, then this one gonna turn to -1. If x equals -1, then this one is 0. If x equals 0, it's -1. And if x equals 1, this one gonna be 4, -4. And again, we have to plot them all in the Cartesian plane, which x and y here. So if x equal negative 3, 1, 2, 3, negative 3. Y equal negative 4, 1, 2. This one is 0, 0. 1, 2, 3, negative 4 here. Okay, so the first point that I can plot is this one. And if x equal negative 2, then y equal negative 1. The second point is here. If x equal negative 1, then y is 0. This point. And then if x equal 1, then y is 4. Is it? X equal 1, then 1 plus 1 is 2, is 4. Yeah. X equals 0. Just 1 second. X equal 1 here and 4 here. So the next point is here. Okay? And then we connect them all together. If x equals 0, then y equal negative 1, sorry. It's going to be here. Here. All right. So I plot them all together. I connect them all together. And this is my parabolas. So this parabola is the maximum parabolas. Maximum parabolas. Why? Because the value of the turning point here get the maximum values, which is 0. All of the values not beside the turning point is smaller than the turning point. For example, at this point, I have the value of y is negative 1, which is smaller than 0. At this point, I have the value of y is negative 4, is smaller than the turning point as well. So this shape is the concave down, or the maximum parabolas, which the value of the turning point get the maximum. Then we have to answer this question. The equation of the axis of symmetry. Look, the turning point is here, and the coordinate of the turning point is negative 1, 0. This one is turning point. Okay? And the line that goes through the turning point and separate the parabola into exactly two different parts is this line. And what is the equation of this one? The equation of this one is x equal negative 1. All right, so this one is the equation of axis of symmetry. All right, what else do we have to learn? And the y-intercept. The y-intercept when x equals 0, so it's going to be this one. This one is the y-intercept. Okay, so the y-intercept is here. Is 0, negative 1. All done. We've all answered the questions.